The second way that people go about this is creating resilient pathways relying on spanning tree protocol. Traditionally, in networking, you're going to have one switch that's selected to a root bridge, and then you're going to designate root ports and designated ports, as well as alternate ports throughout this particular network. So you can see that in this particular case, the pathway to send the traffic out from switch 3 actually has two different paths that it can take, switch 2 and switch 1. Anytime you create a resilient connection or a ring or a loop within a network, you have to have that network blocked at layer 2. If you have an actual physical loop, what happens is the traffic will circle around the network and actually cause the CPU states to elevate to the point where they reach 100%, and none of the traffic will actually cease. None of the traffic will actually go across the network because each one of the switches due to the loop would actually elevate their CPU threshold to a point where it can't pass traffic. So spanning tree takes the place of allowing you to build this resiliency, but having you block one of the particular pathways. So in this case, you can see that switch 3 can send its traffic either to switch 2 and or switch 1, but switch 1 cannot send its traffic from switch 3 over to switch 2 because that path is currently blocked. So to get the traffic where it's intended to go, it will take the primary preferred path from switch 3 over to switch 2. While this is an effective way to create resiliency, it's what's known as a spare tire methodology, meaning that you can't load balance your traffic across the two links coming from switch 3. And there's a convergence time associated with if the primary link were to fail, it's going to take a certain amount of time for the network to reconverge and actually open up that secondary path. So in this case, if switch 2 were to go down and you need to get traffic to switch 1, that would be almost immediately opening up the path to get to switch 1. If the link failed between switch 3 and switch 2, and you can no longer reach that destination, the traffic port on FA01 on switch 1 would move from an alternate or block state to a forwarding state, and your path around the network would go from switch 3 to switch 1 and forward the traffic over to switch 2. During that convergence time, you are going to have a dropout in video traffic. For about 20 to 30 seconds, you are not going to record video. So given that you have a slower convergence time in an outage, this isn't always the best way to accomplish that high availability. But if you can deal with a certain amount of outage or 20 to 30 seconds of video being lost, it can be an acceptable solution.